Here are solutions to homework set number 6 for ECE 376. The first problem is to collect data on your PIC board. In this case, I'm measuring a 100 microfarad capacitor watching discharge across a 100K resistor. So the procedure is I first charge it up to 5 volts, release the voltage, and then let it discharge. As it discharges, I can collect data, which I can see over here, and the PIC flash tool. If I copy to clipboard, I can now go into MATLAB. Again, copy to clipboard, go over to MATLAB. Somewhere there's MATLAB. There it is. Say data is start of matrix, paste, end of matrix, and plot. I get the voltage versus time. So here I held it at 5 volts, let it discharge. There's the voltage versus time. So that was the first problem, collect some data. Problem 2 is now find the equation for that exponential. So here I'm going to do least squares curve fitting. I've got my data. It's sampled every 10 milliseconds. I'll then form my basis function. So I'm going to form the curve fit in this form. I want it to be linear in time, so take the log of both sides, I get this equation. Set up my basis as t and 1 times your unknowns, little b log of a. So this is my basis function, there's a, and the output is log of b. Do a least squares curve fit, and I wind up with, this is b, and there's log of a. From that, I can plot the actual data in blue, my curve fit as an exponential in red, and see that, yeah, that picked out pretty well. So there's my exponential decay. What that'll tell me is that's actually 1 over RC for a resistor. That's the function of the thermal resistance, thermal capacitance of a coffee cup, whatever it is you're measuring. Problem 3 is let's use the chi-squared test. So if I look at the data, I'm going to split it up into n bins, and the bins I chose are 4 volts, 3 volts, 2 volts, 1 volt. Count how many data points are in each bin. I can calculate how many data points there should be. From the exponential, I can find out what this time is, these times. The time spent in the region should tell me how many data points I should get. So, this is how many data points I have at 4 to 5 volts, 3 to 4 volts, 2 to 3, 1 to 2. I can calculate, this is the decaying exponential. How long does it take to get to 4 volts, 3 volts, 2 volts, 1 volt? The difference in time is the time that you spend in the region. That's the probability. So 1.1 seconds divided by 8, it should be in this region, 4 to 5 volts, 13% of the time, 17, 25, 43. I had some number of data points, add all these up, that's the total, that's n. Multiply by the probability, this is the expected frequency for how many data points is in each bin. Here's the actual data. Chi-squared test compares expected versus actual. Take the difference squared, divided by 109, difference squared, divided by 140.9, difference squared, divided by 198. Add them all up, I get 0.22. To convert that to a probability, I use a chi-squared test. I've got 4 bins, meaning 3 degrees of freedom. Go to StatTrek, and I can look at the number of 0.2251 with 3 degrees of freedom. Comes up with a probability of 2.7%. That basically says that a capacitor's discharging behaves very much like an exponential. So it's not too surprising. Problem 4 looks at the following code. Is this a fair die? So this is what that looks like. On my PIC board, I've got my 6-sided die. Every time I press the button, it counts really, really fast. When I release, that's my die roll. So roll to 4, 2, 2, 3, 2. For data collection, it's sending the data to the serial port, which I can collect with the Pick Flash tool. Once I'm done, copy the data to the clipboard. And then in MATLAB, say dice equals start a matrix, paste, end a matrix. And these are my die rolls. I can then find out how many times I rolled a 1. Sum of dice equals 1. I rolled 3 1s, 7 2s, 3 3s, and so on. So doing that procedure, I roll the dice a whole bunch of times. That's how many times I got a 1, 2, 3, 4, 5, 6. Is that a fair die? Well, to do that, compute the chi-squared score. I take the difference squared divided by 25, difference squared divided by 25, add them all up, I get 9.3. To convert that to a probability, I go to chi-squared table, or StatTrak. I've got 6 bins, meaning 5 degrees of freedom. My chi-squared score is 9.32. Convert that to a probability. Probability is 90%. So based upon this data, I'm 90% certain this is not a fair die. It actually is a fair die, just occasionally get unlucky. Didn't get very many ones. But that was my data. Problem 5. Let's repeat, only now. 9% of the time, 1 out of every 11 times, I always roll a 6. Can I spot that? Well, again, I roll the dice a whole bunch of times. Here's how many times I got a 1, 2, 3, 4, 5, and 6. Form a chi-squared table. Take the difference squared divided by 25, add them all up. I get 19. To see what that means, go to a chi-squared table. I've got 5 degrees of freedom. Chi-squared's value is 19. Corresponds to probability 0.9999. So I'm 99.9% certain this is a loaded die. In this case, I could detect it. I had a lot of die rolls. But if you roll the dice often enough, I can spot loading. 9% loading. Number 6. Okay, so for number 6, I'm going to do something similar. I'm going to roll a 3-sided die, but I'm going to predict what the number is. So I think I'm going to roll a 2. It then rolls a 3-sided die and sees, did I roll a 2? If so, I got it right, otherwise I got it wrong. I think the next number is going to be a 1. Got it right. 3. Wrong. 2. 3. 1. 3. 2. 3. 1. Repeat a whole bunch of times. If I'm guessing, I should be right 1/3 of the time. If I'm actually psychic, I'm going to be right more than that. So let's find out. Here's the code. I basically generate a random number, check which button I pushed, that tells me my guess, and then check, did I hit the right button? If so, I increase right by 1, otherwise increase wrong by 1, and display it. So I did that 45 times, and here's what I got. Am I psychic? Well, let's do a chi-squared test. I should be right 1/3 of the time. I did it 45 rolls. I should be right 15 times. That's what I expect. I was actually right 14 times. Likewise for incorrect, take the difference squared divided by expected, difference squared divided by expected, add them all up. That's my chi-squared value. To convert that to a probability, use a chi-squared table. I've got 2 bins, meaning 1 degree freedom. Chi-squared value is 0.1. The probability is 24.8%. So based upon this data, there's a 24% chance that I'm not just guessing, which pretty much means that, yeah, I'm not psychic. Sad, but anyway, that's homework set number 6. With the chi-squared test, you can test distribution and find out is something exponential, find out if a die is fair, find out if a die is loaded, find out if you're psychic. So that's homework 6.